Hi, this is problem number 12 from section 3.3. The video tells you how to do this with calculus. Uh, Being a pre-calculus course, calculus techniques shouldn't be used, okay? Let's show you how to give you a tool so you don't need to use calculus. Um, so what this is telling me, I mean, really the setup's kind of hard at first. I've got this parabola that opens down, it's been shifted up 5, and that's that graph. And then they're telling us that we are inscribing a rectangle with its base on the x-axis. So, and they want us to find the dimensions of the rectangle with the greatest possible area. Well, there's a whole bunch of rectangles we could use. There's the green one. There's the blue one, and which is the biggest area? I don't. Are there other ones that have the biggest area? Well, that's how we're going to find to solve this. Now, the base. Now it doesn't matter which rectangle you're using, whether it's the blue one or the green one or some other one. This is symmetric about the x-axis or y-axis. So each of these is x long, whether it's the blue or the green or some other thing. So this rectangle is 2x wide or long, and its height is described because it doesn't matter if it's an inscribed rectangle, that means the corners are on the curve. And that tells me to get the height of this rectangle, it's going to be an expression. Now, whatever x is, I know that it's going to be 5 minus x squared high. So my area, my rectangle, can be described by 2x times 5 minus x squared. And so this is my area formula for that rectangle. I'm going to distribute that through, and I get this area function based on an x. So now the trick is, how do you find the maximum? It's not a parabola, it's a cubic function. How do we find that? Well, calculus is one way, or the derivatives, but another way is, let's throw it into a grapher. And this is the graph of that area function, right? And it's got to be in quadrant 1, it's got to be positive, and since it's there's some limitations on it, and I know, well, actually, even that, I know this is a cubic function that's been reflected around the x-axis, so I know this isn't going to turn around and come back up, so I know this is the maximum value. It can't be over here because the x's are negative. We want a positive x. So let me erase that so I can see that again. So when x is 1.291, that has the maximum area in that interval. So 1.291. So looking at that graph, I know x equals, crap, what was it, 2.91? I don't remember now, just a minute. I went and looked at the thing and wrote it down. So that's the x value. And that's only one of these distances, and we need to go 2 times that. So 2 times 1.291, and we could multiply that and get the answer. And then to get the height, we get the height by saying 5 minus x squared. So 5 minus 1.291 squared. And that'll be the height, and this will be the length. I don't know which is bigger, but that's what you, and I just did this with one of my Oxbow students who is doing this class. Um, and you can just, to get my math happy, you can type the answers in like that, and you don't have to do the actual multiplication. Okay, so that's how you deal with this question without calculus. I hope it helps. I hope, and don't hesitate to give a yell if you need more help.